Okay, welcome back to Mining Now. Today we have HE Parts on the show, and we're going to be looking at their crushing division. We've got Mike Hammer, he's Executive Sales Manager at HE Parts, and we have Frank van der Heijden. He is the Engineering and Development Manager at Crushing Globally at HE Parts. Gentlemen, welcome to the show. Great to have you on.
Great to be here.
Thank you so much.
We've got quite a bit to cover here. So I think, Frank, we're going to start with, actually, maybe just give me a quick snapshot of just both of your roles. Mike, start with you and then jump over to Frank.
Okay, well, I'm the Executive Sales Manager. I look after our sales teams predominantly in Australia. We're originally an Australian company, so we have our largest sales teams based here, Western Australia and over East, which basically makes up probably 2/3 of our total business. And then we also operate a overseas sales team that operate out of this facility as well.
Yeah.
And presently we're expanding into North America as well.
Yeah, we've covered a little bit of that on some of the episodes. It's and hopefully we're doing more as that expansion continues. How about you, Frank?
Right, I'm the Engineering and Development Manager. I actually started with HE Parts 15 years ago, and I look after all the engineering and drafting, specifically on the crushing solution side of things. So we've got, the team essentially looks after all the line of development, which we'll talk about a little bit more in detail. And we also do crusher spares, reverse engineering and optimization. And the last thing, which we also want to hopefully talk about, is the product development side of things, which is more of the cutting edge technology side of things. So it's an exciting time.
Okay, great. Where are you located right now? It's kind of a cool setup.
We're in Perth, sunny Australia.
Yeah, and is this? Are you actually at a manufacturing facility right now?
That's correct. Yes. So Crushing Solutions, we sort of like grew from this exact spot.
Okay.
We've got all the manufacturing happening in the background. Service repairs, that type of thing.
Can we jump right into the liner development? And give a bit of insight into your process, your capabilities, things like that.
Sure thing. So with our liner development team, essentially what we do is we focus on improving your crusher liner life. So I always like to refer back to it like from a car's point of view. So you get your typical car's parts that you can buy, and then you get your performance parts. That's sort of like where the HE is really renowned for, is sort of like developing these optimized parts and liners to meet specific site applications.
So in a crusher, now I've got a chance to work with a bit, not near the scale you do, but I've got a chance to work a little bit with crushers. So the parts that you're seeing in most crushers, do most of them have aftermarket parts? How often does a crusher come to site ready for that particular environment?
Not a lot, to be honest. When the OEMs do the design of these crushers, they have to try and expand it or make it so that it can suit a wide variety of applications. So, it's one of those things that, it should be something that they can have for pretty much a majority of mine sites that you have. So when we get involved, we do the design specifically for the type of ore that they mine, the throughput that they need, the particle size distribution, and especially, trying to line up with their shutdown schedules, because, each mine site will have different shutdown schedules. So, it's just, for the value add, that's sort of like where we would really benefit them.
Let's talk about our Heavy Industry World Tour, brought to you by Savannah Equipment, supplying mining equipment worldwide, and Corporate Traveler Canada, helping companies travel the globe simpler, faster, easier. We are heading to events across North America and Australia and filming episodes on location. Email us at info@crownsmen.com to be part of Crownsmen's Heavy Industry World Tour. Use drone data to map, measure, and manage your work sites with survey-grade accuracy. Propeller transforms your photogrammetry and LiDAR surveys into a realistic, interactive 3D map. That map is where collaboration happens and accuracy wins every time. It's a cloud-based workspace for project teams to measure and manage their reality in real time from any device. With survey data, designs, measurements, and media in one place, the right data is always ready to go. It's time to replace rework with great work and make great work the status quo. Visit propelleraero.com to learn more. Does your mine plan keep up with changes on site? When it comes to managing a mine, you never know what's around the corner. When conditions change and you need answers yesterday, don't get held back by your scheduling software. With Micromine Elastri, you can explore a broader range of scenarios, rapidly test options, and slash your waiting times. Account for more in your mine plan and be ready with the right answers when questions arise. It's time your software matched the pace of your site's demands. Visit micromine.com/Elastri to learn more.
The mining environment, I want to jump over to total cost of ownership here in a sec, over to you, Mike, but I wanted to just ask, what about the environment first, just understanding, like even in Australia alone, I mean, I know we're going to, we're talking about North America. We've done other episodes with you now talking about moving into Peru and operations in Africa. But I wanted to, even in Australia, like how varying are the actual environments that these crushers are being deployed in?
Well, the environments can be quite varied. They can be from aggregate production, working with quite hard but not necessarily abrasive rock, through to a wide range of different mining materials like gold ores, copper ores, iron ore, and they can be specific for particular, looks like the West Australian flies have got us. They can be ranging in anything from 200 or 300 tonnes an hour plants up to 2,000 or 3,000 tonnes an hour plants. So the capacity and size of the crushers will all be chosen depending on the size of the plant, and that will impact on the durability of the machines. The bigger crushers tend to be designed to be more durable. Also, the type of rock that they're crushing, if it's a highly abrasive material, then that will tend to mean that the life of the wear parts will be lower. And in some cases where the plants are quite well optimized, they run the plants very much at almost a full capacity. A lot of plants are installed with a particular design capacity, say 2,500 tonnes per hour. And the mining operators themselves are constantly debottlenecking the plants, and they'll often 5 or 6 years after the plant's been started, they'll be running at 20 or 30% higher than it was originally designed for. So that puts a lot of extra pressure on the operation of the individual crushers and screening units. And that's what gives us the opportunity to look at how we can optimize the performance of those crushers and how we can squeeze that extra bit of juice out of them, so to speak.
So then Frank, on the engineering side, how often are you engineering based? Like how often are you getting involved before the crusher actually gets deployed versus when it's already been in operation for an extended period of time, and then they're seeing, okay, where is the common place that HE Parts is getting involved?
So most of the time we get involved after the fact. So once the crusher has already been in operation, and that's like Mike was saying, is when the crusher gets started, then they start ramping up production, which then all of a sudden they need to get additional output from these crushers, and that's sort of like where we get involved most of the time. I'm saying most of the time because we've been working with a couple of our customers, and they were moved into different roles, and then with new plants, because we've built a relationship and they know essentially the quality product that we have, we've actually started working with them on new plant designs as well. So, but for the majority of times that we get involved, it's normally just after they had the crushers in for a couple of years.
So, and I'd just like to add to that. That comes about also, though, largely because till they've operated the plants for a period of time, they don't really start getting an understanding of what's working well and what's not. So it's better for them to have some operating experience with the plant, so they can find out where the plant needs some improvement or where it's working really well. And then that gives us better ideas on where we can help the customers as well.
CIM is Canada's leading technical institute dedicated to the sustainability of our industry. Members enjoy professional growth opportunities through CIM libraries, publications, webinars, societies, and the job board. Experience the CIM community firsthand at the Conference of Metallurgists, August 19th to 22nd, ICARD, September 16th to 20th, and the CIM Health and Safety Conference, October 6th to 8th. Visit CIM.org for more information and join CIM today. Falkirk Environmental Consultants transform ideas into sustainable realities. Founded in 2019 by a visionary team including Jen Turner, Max Brownhill, Mike McPhee, and Indigenous engagement specialist Christy Smith. The team champions projects that thrive and respect communities and ecosystems. Falkirk specializes in project planning, Indigenous rights, community well-being, and water stewardship. The team at Falkirk are more than consultants. They are natural resource stewards that support a sustainable future. Falkirk, getting it right the first time. You can contact them info@falkirk.ca to learn more.
I'm always interested on the communication side, and maybe both you can speak to this, but maybe Mike, start with you on it, is that is it sort of scheduled maintenance that's when you're coming in, or how often is that call coming in once there's a problem, once there's an issue, they're failing capacity, or it's wearing out faster than it was scheduled for? What is usually the nature of that first point of contact?
Usually the first point of contact is they want to improve the capacity of the crusher in some way. They don't always know why the crusher's not reaching the capacity that they were expecting it to, or why it's not performing quite the way they want it to. So it might be something as simple as just the profile that's been chosen for the liner parts, and that's the gap that between the two crushing faces that the rock basically migrates through as the crusher operates. That might not be really operating as well as they would like, but it may be other things as well. It may be the way the crusher's set up. It may be the way the feed into the crusher is working. And they'll be looking to us to actually come and do a little bit of diagnosis on what their problem is. And through that, we'll gather a lot of data about their plant. We'll analyse how the crushers are working. And from that, we'll be able to identify what's the sort of root cause of their problem, and then be able to design a solution that will overcome that problem.
Yeah, you guys are just setting it up. You guys are making this too easy. So now over to you, Frank. Now when you know what the problem is, or you know what the optimization should be. And I'm of course learning a lot about HE parts from doing these episodes. I'm starting to understand just the global reach, your supply chain power. Can you talk about actually putting together, based on the different materials, different setups they need, just the scale of some of these crushers you're working with? Can you sort of paint a picture of actually delivering that to the clients?
Yeah, absolutely. So I guess the biggest thing from an engineering perspective is once the sales team have sort of like engaged with our customers and did a bit of a background of what the problems are. Most of the time, what we experience is it's normally one of three things that our customers want to try and resolve. The first one is the line of life, which we spoke about, essentially, trying to make specific shutdown intervals. The second thing is the throughput. They're not getting enough material through the crusher. And the third thing is power draw. So, you're actually experiencing too much power, or it's drawing too much power for what you're trying to crush. So, from an engineering perspective, what we normally do is we will then go to site. We've got some high-tech measuring equipment, some 3D laser scanners. We'll go and essentially start off with not only gathering the machine parameters, the typical materials characteristics that they have, and then also try and see if we can, review or analyze the worn profiles of the crushers. So by looking at the worn profiles versus what it is new, you can sort of like start painting a picture of, what is essentially happening inside the crusher. So once we've got the worn profile and the new profile of the crushing chamber, we've got a couple of software that we've developed in-house called Chamber Vision and Crusher Vision, and those two is sort of like what we run the data through to try and ascertain exactly what's causing those issues that they have, but also then how to optimize or how to improve the chamber to suit that specific application. So the biggest thing for us in short would be, gathering as much information from site as we can, and then also then what their targets, or their wish list would be essentially. And then we work towards a design that meets those criteria.
Is it generally pretty collaborative when they're talking to you, kind of going back to that, what point do you get involved with them? Are they is there sort of some push and pull sometimes because I'm sure they have engineers on site and they have a team of a maintenance crew that maybe has a different perspective. Does it take a lot of communication, or by the time you're in there, are they pretty receptive to what you're doing?
Yeah, I would say for the most part, especially the guys on the ground, they're pretty receptive with what we do because they've experienced this problem and they don't know. A lot of times they like Mike was saying, they don't really know what's the cause of the issue, or they know that they know they've got this problem, but they don't really know what they can do, or what options are available for them to solve that issue. So most of the time when we get involved, doing all the work in terms of scanning the worn profiles, providing them a proposal, it's a lot of times it comes back with a quite positive feedback.
Add to that also, often you're dealing with 2 or 3 stakeholders on the plant.
Right.
You're often dealing with the operators that are responsible for getting the productivity through the plant. You're dealing with the maintenance guys that are responsible for scheduling the maintenance and taking it out. And you're dealing with the reliability engineers that they're constantly looking for ways of improving the performance. You're trying to come up with solutions that meet the needs of all of those people. So production guys, generally, they're chasing tonnage. They want as much through the crusher as they can get. The maintenance guys, they want predictable, reliable maintenance periods. They want to be able to schedule their maintenance out several months in advance of needing to do it so that they can plan, they can get all of the equipment on site, they can get the spare parts, and then they can minimize the downtime and minimize the loss of production for the plant. And the reliability engineers are sort of basically trying to innovate in the most conservative way that they possibly can. They want improvements, but they don't want to do anything that's so radical that it puts the performance of the plant at risk. So they want really steady incremental improvements.
That by the way, that's one of those things that just fascinates me, is the dynamic between different departments all trying to get to maybe not even the same goal, but they're all at least working on the same thing. And then you, as that sort of third party, sort of facilitating that dynamic. I imagine it gets quite interesting. Any projects? I want to move on to some other things, but any projects stand out to you? Just on a large scale, just to give the audience a sense of just how big some of these units actually are that you're working with.
Yeah, so the one that comes to mind is there's a specific gold mine here in WA that we've been working quite closely with for about 8 years now. And, from the start with the OEM liners that they had, they got around 430,000 tons per liner set. That's what they're starting off with. And, throughout the life, or, the small increments that we've done in a matter of a couple of years, we've essentially increased that to a 50% increase to 660,000 tons per liner set. And, there's even further development right now. It's to a point now where we can't really, we're still firming up the numbers, but additional improvement from that is also, on the cards. So it's a pretty much a journey that we have to have with these customers that we have, and it's at the end of the day, as long as our customers work with us to sort of like develop these liner sets, it comes out to a best outcome for everyone.
What an increase! Are they expect when they start these conversations? I mean, I can't do math that quick in my head to the numbers you just said, but that's quite a jump. What are they expecting? Are they expecting 2 or 3%? But when you start getting into that, 10+% production, those are pretty staggering numbers.
Yeah, it makes a significant change. Again, like a lot of times if you have say a typical mine site will have shutdowns every 6 weeks, and their crusher liners only last 4 weeks. That means they have to have a modular shut to essentially, replace the liners prior to the major shut, which obviously have all sorts of additional issues that you have. So if they can line up the liner life with their shutdown schedules, you've got reduced shutdown time, you've got additional or minimal site crew that needs to do the change outs, and essentially just it lessens your total cost of ownership of the machines.
Mike, we've already kind of touched on it, but I want to really paint a bigger picture of just so people understand HE Parts capabilities, because you really are a one-stop shop. I mean, there's going to be people watching that already know this, but there are people that aren't going to know it. So can you sort of give that scope that HE Parts actually offers?
Yeah, sure. We are a one-stop shop. In fact, it's one of the comments that customers that don't know us very well when they first come to the site and they walk around here. One of the first things that they really are surprised about is just how broad our capability is. So we have our own in-house engineering team, which is quite unusual for a lot of companies like us. They quite often they have an engineering team in a different country, or they rely on third-party engineering. We also, as well as selling the actual physical wear liners and the mechanical parts for the crushers, we have our own field service teams that will go out onto sites, work with the customers to do site maintenance, to do planned repairs. And in complementing that, when a crusher has got to the point where it's no longer economic or simple to maintain it on site, but it's still a crusher that can be reused, we have the facility to bring those crushers back to our workshop and actually rebuild them and completely recondition them. We have the ability really for from the operating life of a crusher to maintain it through its whole life, and also to reinvigorate it, to give it a second or a third life.
You must have some decent lifting capacity to be moving those things around.
You need, for the bigger crushers, you need pretty good lifting capacity, sometimes over 100 tons.
Wow.
Some of the components are 12, 13 meters in length, a couple of meters in diameter, can weigh 40 to 50 tons. Some of the main frames on the crushers can weigh 80 or 90 tons. One of the biggest crushers that we've been involved with from a liner development process has got a throughput capacity of upwards of around 12 to 14,000 tons an hour. The crusher itself sits about 8 floors in height, weighs about 350 tons. So these are big mechanical pieces of equipment. They're quite impressive. They're what you see on the these TV reality shows, world's biggest equipment, things like that. So they're quite exciting things to be worked on. But from our process and from where we go, it doesn't really matter whether it's biggest crusher in the market or the smallest crusher in the market. Our process is essentially exactly the same.
Is that actually, that's a good point. Are you working with the tier ones all the way down through? Who's the sort of the client base that you're not just working with, but also going after?
We pretty much work with anybody that's got a crusher. The tier one customers are obviously important customers to us. They're global customers, and they make up a fairly big chunk of our customer market. We're sitting here in Western Australia, once one of the major mining environments in the world. Most of the major mining companies, global companies, are represented here. So we have exposure to global companies in their backyard. And so we work with them, but we also work with the local companies, the local quarries, local industrial minerals. I think everybody knows that lithium is and battery minerals are the sort of minerals of the future. Everybody wants them for their batteries and for powering the decarbonised economy. But those minerals all come out of the ground, and Western Australia is one of the fortunate parts of the world. In fact, Australia, where all of these minerals exist. And so there's constant investment going on in the mining industry here, new players emerging, and we're actively engaged in supporting their operations as much as we possibly can be.
Dovetailing into the conversation about actual lifting capacity, doesn't HE Parts, do you have a new facility coming online? Is that right? I hope that
we do have We do have a new facility coming online. We're currently under construction at the moment. Our business has been growing. The mining industry is growing, and not only that, the equipment that the mining companies are buying has been getting bigger and bigger.
Yeah.
Everything's becoming about economy of scale, and bigger is generally better. Not necessarily true, but for crushing equipment, it's pretty universally true. Tonnages are going up, bigger crushers are needed to handle those bigger tonnages. And that knocks on to the size of facility you need to maintain those machines. And our business has been increasingly seeing larger machines coming in for maintenance, larger components to be supplied, larger wheel liners. And that's driving a decision that this facility where we are here, we've been here for 35 years. It's kind of outlived its usefulness in a way. It's spread over several buildings. It's not as operationally as efficient as we would like.
Mm-hmm.
So the purpose of building this new facility is to enable us to gain some operational efficiency through all being under the one roof, and also to be able to handle larger equipment than we can currently handle.
And just to anybody wondering, we are pushing HE Parts, and we're hoping that this interview will go well enough that we will be doing an interview from that facility. That's our hope.
Yeah.
Frank, I was just wondering, just from the engineering and the capability side, that these with HE Parts, again, because I'm getting more and more context of just the reach and the capacity you have, is it because of that position? How long did you say you'd been with HE Parts?
I've been here since 2008, so 15 years.
So you've always been with HE Parts you've been with them. Is that right? That's when they started, right? 2008 was the first.
So 2008 is when HE Parts acquired crushing and mining equipment.
Right.
But CME was founded in 1988.
Okay, I see. But since 2008, now as the company grows and grows, have you seen, and I'm going to try to not butcher this question because I actually want to understand it, the ability to solve a problem. So if you've, as you get more and more capabilities and have more and more just brain power as different people come into the companies with all this experience and background, is it just getting more, there's just more and more capabilities all the time to be able to solve these issues in a way that maybe 10 years ago you tried, but just wouldn't go at the same rate now? Is that I'm kind of just, I'm stumbling with this question, but is that do you see it?
Yeah, absolutely. So, going back to when I started, a lot of the ways that we do things now, we just didn't have that type of technology, 10, 15 years ago. The first thing, like I mentioned, the laser scanner side of things, actually having equipment that can give you a 3D representation of, the worn liners, and then you can analyze it because, if you look from a crusher's perspective, the inside the head and mantle, that's the bit that rotates, but the concave or the bowl liner, that's stationary. Mm-hmm. So if you do a 3D scan of the entire liner, on the bowl liner, you might actually see some what we call hotspots, or areas that have got significantly more wear than other areas. So that you might, if you 10 years ago would have done a quick cross section of the bowl liner, what you would see if you didn't take it over that hotspot would be, yes, no, those liners are still fine, you're good to go for next couple of weeks. But only to find out 2 days later that you've got that where that hotspot is, you've started cracking, and you've got a premature failure. Now with the laser scanners, we actually have that capability to analyze these liners as a complete package, and then identify what we need to do, whether they need to change the way that they feed the crusher, or other methods. The other thing also that we have started doing is DEM, which is discrete element method modeling, which is essentially particle simulation. So beforehand, now with all the technology and computers and simulation type of software, we can now run a specific PSDs, a particle size distribution of a mine, how big these particles are that goes through the crusher, and we can simulate how the crusher will react, not only between the two faces of the crusher with the particles, but also what we call interparticle crushing. So, looking at the fracture points of each of those particles in between each other as well. So you can more accurately predict and simulate what's happening inside the crusher these days than you would do, 10 or so years ago.
Some of the things you're talking about. So I've started this is just a personal campaign that I've actually just recently undertaken, is that I think there's a big thing about, you can like find it online. A lot of people talking about it. They say like your phone, like everything in it comes from mining or in the car and that. I go, yes, that is great, but that's already in there. People don't care about that. I'm trying to convince people in the mining industry, show the public some of this equipment, because people like big, cool things. Just start showing them that. If you want support for mining, start showing them that. I don't know if I'm getting 100% following on this yet, but I'm going to get there. And it's kind of joking, but I do think people, if they understood just the level that mining is now operating at, the technology that's going in it, I don't think people realize it, that it's what's in your phone. They go, oh, okay, well, thank you. But when they realize what it takes, we've got a bridge getting built outside of our apartment, and you see what it takes to put that bridge out, to put it up, and just the amount of just ingenuity and engineering that actually takes to go in, you can't help but be impressed. So anyway, that's my little campaign. But the other thing is, what about things like wear sensors and just that sort of thing? Is that becoming part of the operation as well, or is things you're offering?
Yes, absolutely. So, the digital era is here, especially in mining, so, and I want to say crushers, were pretty much designed 50, 60 years ago. And, there's not really a lot that's changed in the bare mechanics or the basic mechanics of how they work. But, we started looking at the digital side of crushers, a couple of years ago, and we've recently had a patent granted on installing wear sensors in crusher liners. Now, this is an absolute game changer for us because, as I mentioned before, is that, for us to be able to do our analysis and performance optimization, we always need to go to site, have the 3D laser scanner, scan the worn profile, get all the operational data, run that through software, internally, and then develop what the new profile needs to be, get sign off from the customer, and away we go. With wear sensors, the idea is that you get real-time feedback inside the crusher, so the wear rates and everything on the fly. So you can log in and essentially see what your wear measurements are on the profile at any given point. So what that would do is when you incorporate that with your operational data, you can then exactly say when your liners will run out of life. Do you already have any particular areas of concern that it's not going to meet your shutdown schedule? And the idea of that is then would be to then get that flag, from a HE parts point of view, and call up our customers and say, hey, something must have changed. You could have hit a different, the ore characteristics where you're mining right now could have changed, which accelerated the wear. So because of that, you're not going to make your shutdown date, which you've planned for. Do you want to bring in stock early for change outs? So, all of those types of things you can do now with getting that data in a real-time space. The other thing also is what they do. One of the key things for a crusher is your closed site setting, your CSS, which is essentially the gap that you're running the crusher at. So up to now, a lot of times you actually have to manually set the gap, and it's a pretty agricultural way of doing it. You have normally a block of lead or something that you throw down the crusher while it's running. You pull it out and you sort of like measure it to see what the gap is of that crusher. Having sensors in on the liners themselves means that you already know what the measurements are of your liners, so you already then know what your gap is. So there's no need to do manual gap settings at all. So there's a number of benefits by using these types of sensors in the crushing environment. And we're pretty excited to see how we can roll this out into all of our customers.
Mike, I feel like on the sales side, if you start telling people that's coming, they're just going to say, yeah, and when is that? That doesn't sound like a hard sell to me.
For sure, we've got a lot of interest from our customers about it. I guess the mining industry, in one hand, can be quite innovative. At the other hand, it's a bit conservative.
Right.
So they definitely want the technology, but they also want it to be well proven, reliable, and durable. So that somebody has to be first, and we've been fortunate that we've got a few customers locally that have been happy to work with us doing trials and through the development process. The more sophisticated customers will be early adopters of this because they're aiming all the time to try and minimize the amount of intervention that somebody personally has to do on a crusher. They want to make them as automated as possible. They want as much sort of stand off or stand back management of the crushers. So anything that can reduce the amount of personal intervention on that crusher will be very attractive to them.
Right. Is that, have you noticed, and either one of you can answer this though, have you noticed a shift from, let's say 10 years ago, you came out with this and said, okay, we're going to start utilizing wear sensors, that maybe that takes 2 years to adopt. Now it might take a year. Would that be accurate? Or is the mining, I mean, it still has to be proven and everything like that, but is the mining industry on a whole, do you think, a lot more receptive than it was, let's say, 10 years ago?
I would say so, yes. They are definitely more. I think it's also to do with, everyone is pushing their machines to the max at the moment. They are trying to get the best out of each machine that they have or each asset that they have on the ground. So in order for them to improve or increase capability or capacity, they do need to look at all these different alternatives and options available for them to be able to get that increase that they're after. So beforehand, where they were more conservative and, if it works, don't fix it type of thing. Now everyone's, looking elsewhere to see what's the edge that they can get out of their machines to improve it. Even like you say, just incremental percentage improvements is something that, a lot more customers would be willing to adopt now than what they would have done, a couple of years ago.
Yeah, it's a fascinating time to be in mining, really. Just as we get to the tail end, I just didn't want to I don't want to miss anything if there's, either a product line or a service within this crushing space that AG Parts is offering to your clients. Anything you want to touch on before we wrap up?
Well, I think it's important also to recognise that whilst we've been talking entirely about how do we improve the performance of the crushers and get them to last longer or operate at a lower cost, another aspect that's equally important for all of our customers is safety of their people on site. Mm-hmm. So a big part of our design work is also to ensure that the items are safe, that can be lifted safely, that they can be manipulated into the crushers. And one of the things that we've developed is our own proprietary safe lifting system for both jaw liners and for cone liners, what we call a safe lift. And this has been very popular with customers. The traditional way of lifting manganese out of crushers used to be to weld a bit of a steel lifting eye onto them and lift them that way, but that was unreliable. You're welding two dissimilar metals together. You're reliant on the welding skill of the guy doing it in the field, and so you're running the risk that the weld will fail and the liner will drop in an uncontrolled way and put somebody's health at risk. Potentially, even in some cases, these liners are big enough to kill people. So it's really important from a operational and safety point of view to make sure that whatever we design can be managed and manipulated in a safe way.
Yeah, when you talk about safety, to different people, safety means a different thing. And anybody though that's seen, I've been under a piece of equipment. We thought it was light. We thought it was thin little kind of tin material. It wasn't. And fortunately, when it dropped, I was sort of back, so it almost like did that like a bow. It just sort of zipped me back and like kicked me out of it. I mean, if I had been just a different angle, I would not be here doing this interview. So when you talk about safety, you know, to anybody we have a host, Roy Slack, who is here in Canada, but in the US, and he hosts for us. I mean, he is just things he's seen and experienced. I mean, his level of safety. How important is it now in these conversations, even from just your client's perspective, just showcasing the level of safety that you can operate on at their site for their people? What's the conversation like in that setting?
Well, I think it's a pretty basic requirement to be able to do business. If we can't operate safely, if we don't provide safe equipment, then we won't have customers interested in us. It's just a qualification you've got to be able to do, and to meet the not only the society's expectations, but also the industry expectations. And mining gets a lot of scrutiny. It's a high risk industry, and accordingly, there's twice as much care put into safety on mine sites than you would see in most other environments.
Yeah.
And so fundamentally, safety is the number one priority for every site we go on, and within our own sites as well.
Yeah, it's a good, you know, mining. I mean, obviously, historically, I think everything historically has had its bad marks, but now it's like anything that anybody I talk to, you know, workers expect to be safe. They expect, you know, equipment operators expect things to be safe. That's a great shift that mining has really done. I think they've done a really good job with. Frank, any other any product lines you want to highlight before we wrap up?
Yeah. So the only other thing that I also want to mention is, you know, when you were talking about technology and how the crushing technology is evolving, one thing that we've also started seeing quite a bit is MMC liners, which is called for metal matrix composite liners. Essentially, you know, instead of having a uniform material like a manganese steel that these liners are made out of, essentially what you have is these inserts that get cast in the liner as well, which is predominantly a lot harder than your base material, and that takes up most of the wear. So, you know, it's not specific for it's not suited to every application, but there are instances where the MMC liners are essentially, you know, will blow typical uniform material out of the water. We've essentially have done a development for one of our customers that they've seen 200% increase in life when they've moved over to MMCs. Now, like I said, it's definitely not something for each application, but when it is something that aligns, it's definitely worth considering.
So would this be maybe this is a bad example, but like bucket companies, they're a lot of times putting different wear parts so it's like a different material on a high abrasive area.
Correct.
That kind of right?
Yeah. Well, yes. So essentially with manganese steel, so the crusher liners historically has most of the time been made out of a grade of manganese steel. Now, your typical grades that you would get is 14% manganese, which is what they call Hadfield steel. Then you get 18% and 21% manganese. Now, each one of those manganese, the percentage of manganese changes because you get additional work hardness and you know, improvement in life essentially. So when manganese in its raw state would be about a 250 Brunel hardness, where once it work hardens, it goes up to about between 400 and 450 Brunel. So because of that thin layer that's hardened, that's essentially what's giving you that longer life. Now, having something in there, which is the MMC inserts, that even pushes the hardness further up to about 600 to 650 Brunel. And that, like I said, that's essentially what's taking most of the wear component of crushing the rock, which then will increase the life of the liners, you know, in total.
You said that some applications, what would be an example of where it would be applicable and where it would not?
We've found that, and Mike can probably look at giving us some other examples as well. But, some of the quarrying industries, we've definitely seen it being beneficial. And we've also got so the ones that we've seen the most in would be jaw crushers. A lot of the jaw crushers would have a good benefit with using MMCs. Some of the cone crushers might get it, but it again would depend on the actual ore that that's being crushed.
Yeah, I think it's still quite a new material that's available. So we're still learning exactly how to apply it and where the best applications for it are. But we're certainly seeing in jaw crusher applications, it's consistently giving this 200% or better improvement in performance.
Yeah, as soon as you said about that,
yeah.
I was thinking, my mind went to jaw crushers as soon as you said about that.
Yeah.
So that's a key place for it, you'd think, right?
Yeah, for sure.
Yeah.
It's like all wear materials in crushers are basically a trade-off between being highly abrasive resistant, which can make them brittle, and then being durable and malleable so they don't break and fracture. So manganese has been popular because it's, through its work hardening, it's been able to have this combination of wear resistance and durability. And these MMC liner options are really enhancing the wear resistance without compromising the durability.
That fly tried to get in on the show there.
Yeah.
I thought it was on my screen for a second. No, that's you.
No, we don't charge extra for those. They come as part of the package.
Gentlemen, it's great to have you on the show. These, people have heard me say it before, but these episodes where we get to have the same company on and get to sort of peel back the layers, it just makes it so much more fun, because we wouldn't have this conversation if we were just doing a general conversation about HE parts. But this is fantastic. And I grew up actually around the crushers and the conveyors and all that sort of stuff. So it's a little extra bonus for me to get to do it. So
nice.
Thank you very much, both of you, for taking the time to do this episode. And I certainly hope it's not the last time we have you on the show.
That's been great. Thank you very much.
Thanks for having us.
Thank you. And thank you, everybody, for watching. We will, on the HE Parts website, they have a place that's specific to, you go into mining solutions, and we're going to put links to all this. And then you can actually see some of the product lines and the offerings within, and crushing solutions. They have a specific page for that with a whole bunch of subcategories as well. So go check that out. Follow them on LinkedIn. We'll have links to that as well. Please keep subscribing to us. The amount of support we're getting, especially from the Australian market, has just been amazing, building on that North American audience that we have. So thank you, everybody, for watching, and we will see you on the next episode of Mining Now.